and enjoying learning vector calculus. So, in today's video we are going to talk about, we have already talked about curvature, but we would like to see there is a famous curvature formula which we study in calculus and what we have done here in vector calculus, how we can relate. Obviously, the same thing we should like different formulas, if they are for the same thing, for example curvature, then they should give us the same end product, right. So, let me first tell you what is the famous formula I am talking about. So, we know from calculus that if y is equal to f of x is a curve, then curvature is given by f double prime x modulus divided by 1 plus f dash x square raised to power 3 by 2. So, I will not derive this here, you can just revise your calculus notes and see how this formula was actually derived. So, here we will be doing, okay, if this is the curve given to us, then we will use the information which we are doing for last 2-3 videos about curvature, and we will find out, we will try to reach at this same formula which we have from our calculus class. Okay, if I ask you that this is your curve y is equal to f of t or f of x, whatever you want to call it, let me just write f of t. So, that means my parameter is t here. Okay, so, it means that for t, the value of the curve point on the curve is t f comma t f of t. This is my x t vector according to our notation, right. For t on x axis, f t is on y axis, right. Okay, fine. So, it means that my x t vector is t I vector plus f t j vector, and now if I ask you calculate the curvature using this vector calculus which we are doing, you will try to find out t vector, this was unit tangent vector, and then you will try to find out dt by ds, and it is equal to kappa times the normal vector. So, you have to basically find t vector and nt vector, right. So, we already know how to find t vector. For that we need x prime t, that is 1 because derivative of t is 1, I cap plus derivative of f is f dash t j cap. Now, we look at the modulus of x t vector prime vector. So, that would be 1 square plus f prime t square. So, that would be 1 plus f prime t square square root. So, this is our x prime t modulus. Therefore, our unit tangent vector is going to be x t divided by modulus of x prime t. So, that is going to be 1 I cap plus f prime t j cap divided by square root of 1 plus f dash t whole square, right. So, this is our t vector, we can write it like this, 1 upon 1 plus f dash t square, this is my I component, and then f dash t upon square root of 1 plus f dash t square j component, this is my j component. So, this is my unit tangent vector. Now, if I want to find out dt by ds, that would be dt by dt divided by ds by dt, right. So, that would be, so we have to differentiate this with respect to t, and if you look at ds by dt, we know that this is equal to x prime t mod. Okay. So, this you can, if you are not familiar with this thing, you can watch like last 2-3 videos. So, this is equal to, this already we have, this is equal to this. So, we will write it as 1 upon 1 plus f dash t square, then derivative of this t vector is here. So, derivative of this, so that is going to be 1 upon 1 plus f prime t square I cap plus f prime t upon 1 plus f prime t square j cap, right. So, we get that dt by ds is equal to 1 upon 1 plus f prime t square. Now, you differentiate the components, you will get dy by dt of the first component 1 plus f prime t square, that is I cap, plus dy by dt of the second component is f prime t 1 plus f prime t square j component, right. Now you know how to differentiate this and this. Okay, so we will be using, here we will simply do it, here we will use quotient rule. So this first thing here is minus 1 by 2, 1 plus f prime t square raised to power 3 by 2, then chain rule 2 f prime t f double prime t I cap. Okay, so and the second here I am going to use quotient rule. I am going to use quotient rule. So, for that it would be plus the square of the denominator, that would be 1 plus f prime t square raised to power half raised to power 2, that will cancel, and then keep the denominator as such 1 plus f prime t square and differentiate the numerator. So, that will be f double prime t, and then keep the numerator as such and differentiate the denominator. So, that would be 1 by 2 1 plus f 1 by 2, just differentiate the denominator. So, it will be in denominator 1 by 2 1 plus f dash t square, and then you have to differentiate 1 plus f dash t square. So, that would be 2 f dash t f double dash t, right. So, this is j component. So, this is equal to, and in the front we have 1 plus f prime t square. So, this is equal to 1 upon 1 plus f prime t square, and inside here you see 2 and 2 cancels. So, the first thing we have is minus f prime t f double prime t I cap upon 1 plus f prime t square raised to power 3 by 2, and here you try to simplify this expression. So, for if you do so, you will in the denominator you will get you have this thing, and then you will take the you also have this thing, right, and let me cancel something, 2 and 2 cancels, right. So, if we do this thing, I will get 1 plus f prime t square raised to power 3 by 2, because power 1 here and half here will be added, and then you have 1 plus f prime t square times f double prime t minus you have f prime t square f double prime t j component. Okay. Now, here you can very clearly see that this, when you multiply and this, they are same with opposite signs. So, they will be cancelled. So, we will get this is our, this was our dt by ds vector. Okay. This was our dt by ds vector, but remember that whatever is inside, because we will need it, whatever is inside, that is dt by dt. So, do not merge for now. So, you will get 1 plus, I will tell you why in a moment. Okay. So, inside I have minus f prime t f double prime t I cap upon 1 plus f prime t square raised to power 3 by 2, plus here this and this cancels. So, I have f double prime t, okay, j component divided by 1 plus f dash prime square raised to power 3 by 2. Okay. So, this is my dt by ds. Now, what I am trying to do is I am trying to write dt by ds as kappa times n vector, and this is kappa which we are looking for. So, I should know what is my n vector, right, then only we can proceed. So, if I ask you what is n vector, if you remember, that was t prime t divided by modulus of t prime t. So, that is why I was telling you, do not merge this fellow here is our t prime t, right. So, this here is t prime t. So, we already have t prime t. So, we will just write it like this, minus f prime t f double prime t I cap divided by 1 plus f prime t square raised to power 3 by 2 plus f double prime t j cap divided by 1 plus f prime t square raised to power 3 by 2 divided by their modulus. For modulus we have to do I component square plus j component square. So, that will be, if you do I component square here, you will get f prime t square, and then you have f double prime t square divided by 1 plus f dash t square and raised to power 3, because 3 by 2 and 2 will be cancelled, plus here if you do, that would be f double prime t square. In the denominator you will have 1 plus f prime t square raised to power 3. So, calculations are little longer, but it is beautiful, right. We should, if I tell you some formula which is new, you should always ask me, right, what is the connection with the formula which I already know, right. So, that is the way we should always study maths. That will, give you so much information which is actually useful, and your maths will be improved, right. Okay. So, now here if you look at, you have to try to simplify this. It is very easy to simplify because the denominator is same, and in the numerator also we can find something which is common. This thing is common. So, I will take it out, f t double prime t square, then inside I have 1 plus f t square, and in the denominator I have 1 plus f prime t square raised to power 3. So, this power will cancel. So, that will be, so I have in the denominator I have square root of f double prime t square divided by 1 plus f prime t square, and in the numerator we have this thing, right. So, further you can write it like this. This is ditto whatever is that component. Let me write down that now. Okay. So, you have minus this thing I am going to write, minus f prime t f double prime t divided by 1 plus f prime t square raised to power 3 by 2 I component, plus f double prime t 1 plus f prime t square raised to power 3 by 2 j component, and in the denominator this square and square root will cancel. So, I have f double prime t upon 1 plus f prime t square. It is a square inside also, right. Now, you can cancel, you see f double prime t cancels throughout, and this fellow also cancels. So, this was our anti vector, right. So, you get minus f prime t upon square root of 1 plus f prime t square, because 3 by 2 minus 1 will be square root I cap, plus 1 upon 1 plus f prime t square root j cap. So, this is my n vector, right. Okay, fine. So, now you have n vector, and this is my dt by ds. Now, you take your things common. I have my n vector and also I have dt by ds. Now, I will try to take my things common. So, if you do so, what you will get, this is common, and in the denominator you can take 1 power, because I want to keep half power inside, because n vector I want to make it. So, 1 power I will bring it out. So, this would be f double prime t divided by, I am taking 1 power out. So, that will make 1 plus f prime t square raised to power 3 by 2, and inside you will be left with minus f prime t 1 plus f prime t square I cap, and then you have the second component is 1 j cap upon 1 plus f prime t square. Now, look at this quantity here, this is nothing but your n vector, this here is your n vector. So, you get that dt by ds equal to f double prime t upon 1 plus f prime t square raised to power 3 by 2 times n vector. So, that gives us whatever is this quantity here, its magnitude is kappa. So, kappa is f prime double prime t modulus divided by 1 plus f dash t square raised to power 3 by 2. So, this is our famous formula for calculating our curvature, right. So, I hope you understood it, right. So, let us just take one example. I want to use this formula to find out the curvature of the curve log of sin x. So, find the curvature. So, it is your choice what you want to use, which formula. So, I am using this formula. Whenever you are given like this, go for this formula. So, f dash x is 1 upon sin x, and then you use the chain rule. So, that would be cot x, and f prime x, double prime x would be minus cosecant square x. So, curvature is f double prime x modulus divided by 1 plus f dash x square raised to power 3 by 2. So, that is equal to minus a modulus of minus cosecant square x divided by 1 plus cot square x raised to power 3 by 2. So, that is minus, that would be plus cosecant square x divided by cosecant cube x. I am sorry, I wrote cosecant cube x, because 2 and 2 first this is cosecant square x, use your trigonometric formula, and then 2 and 2 cancel. So, this is cosecant cube x. So, this is 1 upon cosecant x, that is sin x. So, the curvature for this particular curve is sin x. So, I hope you understood. If you have any doubts, please write in the comment box. Please share this video, subscribe to this channel and keep supporting. Happy learning.